I think we got everyone in here. Chris is just scanning in some final people. So next up here in the leadership group, we have Nancy Hill from AECOM, and the title of the presentation is Using Benchmarking to Improve Water, Wastewater and Stormwater Management. Nancy is a project manager of the Canadian Infrastructure Benchmarking Initiative. She's been working in the planning, design, maintenance, and financing of municipal infrastructure for over 25 years. Nancy Hill is a former employee with the City of Vancouver, but now works with municipalities across BC, Canada, and the US. Let's give Nancy a warm welcome.
And some of you, thank you, everyone. Some of you might recognize the photo. You got, yeah. Very good. So I'm just going to do a brief introduction of talking about benchmark. What is benchmarking? What is the Canadian Infrastructure Benchmarking Initiative? But then I won't go too late. I'll get into the good stuff, the data, looking at trends. What have we found from benchmarking? What lessons can operators, water, wastewater operators learn? Any questions along the way, please just ask. So the idea behind benchmarking is when we're not back in high school, it's not about grading, it's not A's, we're not giving out A's, B's, and C's and determining who's the top of the class. It's about comparing performance outputs with yourself over time or with other municipalities. It's not working. Oh, okay. Yeah, okay. So the idea is to, again, is not to compare about like who's better, who's worse, but to say, okay, how am I doing? How do I compare with other municipalities? Am I doing more? Am I doing less? And to ultimately, the idea is that everyone can improve. So when you can compare yourself against other utilities, you can figure out, oh, okay, maybe I'm doing too much maintenance. Maybe I'm not doing enough. Maybe I don't have enough staffing. And then you can improve your own processes. And ultimately, of course, because the question you get is, are you providing value for money? And ultimately, that's what you need to be able to answer. A little bit of background, this benchmarking project, it used to be called the NWWBI, or National Water and Wastewater Benchmarking Initiative. We had to change the name because we brought on stormwater, and then we brought on roads and solid waste. So it became the Canadian Infrastructure Benchmarking Initiative. But it all started in 1997. There were 4 municipalities. You may not know this, but Capital Regional District, Metro Van, I'm going to say Alberta Capital Regional District. Someone's correcting me here. And was it or maybe it was Edmonton. Anyways, one other municipality got together and they said, we're working in a vacuum, but I know there's dozens of utilities who are doing the exact same thing we are. Like maybe we should start talking to one another and start comparing. So in 1997, they started that. And then in 2001, there was a big expansion. And now the project has about over 40 municipalities, regional districts that look and compare how they perform with in the management of Canadian infrastructure. Again, as I brought up, we've got 7 service areas. I know the folks in this room don't necessarily interested in all of them, but there's water treatment, water distribution, wastewater treatment, wastewater collection. So that's probably what this group is interested in. There's also solid waste, stormwater, and roads. Okay, so why benchmark? It is a bit of work, so why bother? The idea is about, and it's the buzzword, right? Levels of service. How do we know what level of service we're providing, what level of service we should provide, what can we provide? And so to identify what you're providing compared to other municipalities and to be able to communicate that to your staff, to management, to council, to boards, to the public, and to be able to actually measure it. And so a lot of utility operators have a sense of what's happening, but it's nice to be able to put some numbers behind it and it allows you to articulate and it allows you to sort of business case and prove what you already have an inkling of. But if you've got the numbers to support, you can, it's something that you can take to council, you can take to the board, take to public, and help you as you try and endeavor to improve your operations. Another big thing is about it provides it's like this. It provides network peer-to-peer sharing. So it's like, hey, you know, if you contracted out your CCTVing, yeah, I did. Is it working better for you? No, we brought it back in house. Things like that, and you can have a lot of those discussions amongst the group. So that's one advantage. And then, yes, I already mentioned it's a large part of the data is about building your business case. And I've seen it being used in the craziest ways. They've, one point, I think there was one landfill, they discovered that there's been crazy fraud going on and that people were dumping tons and tons of stuff and being charged like $5. And anyways, through the benchmarking data, they discovered this internal fraud scheme that's been going on in their landfill for years, apparently. I've also one where a resident had a basement flooding and the resident sued the city and said, you're not maintaining your system. And through the benchmarking data, they were able to say, actually, we're doing better than the median. We're doing better than most municipalities across Canada. And the case was thrown out of court. And so that's usually not how it's used. It's usually about identifying opportunities to improve your operations, but sometimes there are other crazy uses that come into it too. So what does benchmarking, what are the major outputs from our benchmarking produce? We produce graphs that show key performance indicators. So things like emergency repairs and downtime and number of complaints. I'll be showing some more of them. So reams of that, more, lots and lots of data. But they'll also, there's also a summary report that summarizes all the key performance indicators, who participated in all the data. And then on top of that, though, we don't want it to just end with the data because data is only good if you actually use it. So there's a lot of work that's going on within the benchmark, and we call it process benchmarking. So the top we call metric, just the data. But below that, it's like, okay, how do you use the data? And so we might identify groups that are really focused on water loss, AMI, source control. And so they'll get together and maintenance planning, and they'll get together and discuss topics and work on information, work on those kind of detailed tasks together in a sort of a team setting. And we do that through webinars, in-person workshops, task forces. Oh, and another thing we do that's quite handy is surveys. So a lot of time municipalities will have a question like, oh, what's one of them? How do your field staff record data in the field? You know, do you have laptops? Is it mandatory? You know, do you still allow for paper to pen? And so then, you know, and what if you do, what laptop, you know, what tablets do you use? What software do you use? That kind of thing. And we'll send out a survey out and, you know, get about a dozen responses within a week of what other municipalities use. So brief. Now, the other thing that this whole thing is people ask, well, how can you compare? You know, you've got Halifax, you've got Victoria, you've got Saskatoon. And the idea is that really everyone is trying to achieve the same goals, no matter where you are. You know, you want sufficient quantity. You have to either bringing the water in or sending the sewage out. You want it to be reliable and sustainable. So you want to minimize disruptions, emergency repairs. You want to protect the environment of what you're doing. You want satisfied and informed customers, a safe and productive workplace, and you want to protect the public, their health and safety. But you want to do all of that at the minimum cost. And so we decided everyone's trying to achieve those goals. So we developed KPIs under each of those goals. And that's what the key performance indicators that we measure and compare amongst the group. Okay. So now we get to the good stuff, which you guys might be more interested in seeing. And I just pulled up a few highlights of some of our data. We produce these graphs in Power BI, and you'll see each bar represents a utility, a municipality, or a region. I don't have the names listed here. And one of the things is within the project, we have sort of an agreement of confidentiality. The reason being is people are very open and honest, and they pull all the skeletons out of their closet and they show themselves warts and all, with the idea that this isn't all going public. So whenever I present this information out in the world, I just take off all the municipalities, but these are individual municipalities. So we have main KPIs, so those are the bars, and we sometimes will use a related KPI on the right side here, and that's the dot, because we like to compare, like, is there a relationship? So what this graph shows is the number of main breaks. So how many main breaks do you get per 100 kilometers of system? And we always normalize it by something so you can kind of compare one municipality to the other. But then we say, okay, what is the average age of your water mains? And this is the related KPI in the dot. And you can see it's not uniformly, it's not like a 1-to-1 ratio, but there is a general trend, not a surprise, that the systems with older pipes generally have more water main breaks. And the other thing to note is that the average age, so you get a municipality out here, and their average age of their water mains is 60 years. Okay, so not a surprise, that's average. So not a surprise they're going to be getting some water main breaks. But then you've got some younger, newer municipalities where their average pipe is closer to 20. So there's quite a range across the countries. Some of these are BC, but this does represent municipalities across the country. So that's really interesting to see. Any questions? If you guys don't understand, I see these all the time, so. The other thing we like to do is that graph I showed you before was different cities. This graph is one city, but it shows trends over time. So if a municipality has been participating in benchmarking for a while, we've got 8-9 years of data. And so what you can see here is the number of main breaks, and you can see a wave. So they had a huge, quite a lot of main breaks over here. It dropped quite a bit. Maybe they got rid of their AC mains. And then you can see it starting to climb up a bit. Maybe that led to some renewal of some of their system, and then it starts to decline, and then it peaks up again. Certainly around COVID, some of the activities, they didn't get to, a lot of their maintenance and renewal. So there was a bit of a lag. And so this is very common for a municipality to see a trend of main breaks over time, kind of waxing and waning, depending on what's been happening. And of course, we have our annual workshop. This is pictures from our last workshop in Victoria in April of this year. And it's a great way to have like this, smaller rooms, discussion-based breakout sessions. We do have, as I mentioned, we do send out surveys. Here are some examples of some surveys that we send out, whether it's water distribution system monitoring, organizational structure of your O&M teams, maintenance hole and pipeline inspection programs, fats, oils, and grease, things like that. Anyways, some of the topics that seem to be really hot topics right now. Big one is chemical prices. So we have a task force looking at increases in chemical prices, and AMI is another big one. And again, as I mentioned, the confidentiality agreement. So that's why everything will be anonymized. It's an annual process, so municipalities will, so we collect data every year, and it's up to municipality whether they want to participate, which modules each year. You try it one year, you don't like it, you don't do it the next year, or you like it, you keep it on, you do it again next year, so it's sort of an annual process. Okay, I'm going to show you some more data. This is an interesting one. So this one looks at how quickly are you responding to emergencies after working hours? And a lot of municipalities struggle with this. How do they organize their shift work? Do you have people on call? Do you actually have the works yards manned, for how many hours, just to do 8 hours, or do you have like two shifts? And so the interesting thing, there are two things that you can see here. One is, what is your target response time for emergencies after working hours? This is for the water distribution system. So you can see it ranges from a lot of municipalities, 2 hours. They want to be able to be on site assessing the situation within 2 hours. Some municipalities, it's 1 hour, and other municipalities say 30 minutes. Even if it's after working hours, we want to be on site within 30 minutes assessing the situation. Whether municipalities achieve that or not, well, you can see with the bar. Most of them achieve it 100% of the time, but not always. This is another interesting one, water pressure complaints by customer. So usually it's like 99% low water pressure complaints. People rarely complain about high pressure, although there are a few spots here. You can it's hard to tell on this. You can see it easier on mine. There's a little bit there. Those are high pressure complaints. Again, does it correlate with your operating pressure? So you can see the range of operating pressure from over 60 meters of head to under 10 meters of head. Not really, I would say. Maybe slightly. So there's other things at play. This one, valve cycling. Again, I'll go through each of the modules. I'm just doing water distribution. I'll get to water treatment, wastewater collection, wastewater treatment. So if that's your area, don't worry, I'll get to you. This one is looking at the valve cycling program. So how often are municipalities cycling their valves? Some municipalities are doing it 100%. They're getting every valve every year. But there's some municipalities that are down around 6%. They're cycling maybe 6%. And when there's one municipality that's not doing any valve cycling. The other thing, the related KPI, the dot will show you is how many inoperable or leaking valves do they have. So obviously the more you cycle your valves, doesn't necessarily mean you have more leaky valves. It's just that you find them. Sort of a yay boo situation. The next one looks at customer days without service. So again, this is very much a level of service that your customers care about. And it can be a result of water main breaks, service breaks, things like that. And the reason I put this graph up here is because I remember I was at one of these conferences and someone talked about the importance of valves in terms of water main break management. And the reason being is like, don't worry about, having new water mains. Just make sure your valves work so that when they do break, you can contain the number of customers that it impacts. So I thought I would compare customer days without service with those that do a lot of valve cycling. And yeah, maybe there's a correlation. I'm not sure, but again, it shows the range. Okay, for those who are interested in water treatment, you might be interested in some things like this. O&M cost. So how much does it cost? So per megaliter of treated, what is your annual cost for your treatment plant? O&M, not including capital. So you can see there's quite a bit of range, from looks like 50-ish dollars per megaliter all the way up to 800. There's usually an economies of scale. Smaller plants tend to cost more per megaliter treated than larger plants. The other thing that I thought was interesting is I thought, well, let's look at the last year. How long has it been since that plant has had a major upgrade? And there does seem to be a correlation. The plants that have a higher O&M cost tend to be on this side of the graph, and those are the ones that have gone longer since they've had a major upgrade. So, I mean, this is things that you kind of know intuitively, but it's kind of nice to put some numbers to it and be like, yeah, if I can't upgrade my plant, it's going to cost me more to operate and maintain it. The other thing this graph shows is the different types of costs. So how much of it is for chemicals? So you can see some plants, and it's harder for you guys to see the colors up here, but this is, for instance, chemicals. So this plant, whatever it's dealing with, it's got a lot more chemicals. And then some energy, equipment, materials, external contracted services, and internal contracted services, and all the other things. This one, again, I wanted to show the economies of scale. So these are the larger plants, and these are the smaller plants. So O&M costs per megaliter treated. And this shows the average day demand. So as you can see, exactly as I mentioned before, the larger plants, they're going to have economies of scale, and it's going to cost a lot less, all the way down closer to 100. And you've got some plants that are closer to $400 per megaliter. Again, a really big topic of discussion, chemical costs. And you can see this one particular municipality. So the bar shows the municipality. The different lines show you got the 75th percentile, the median, and the 25th percentile. So not only are you looking at municipality, but you're looking at the group trend. And it's very clear that over the last not even 10 years, it's more than doubled chemical costs for this municipality anyways. Yeah, so this will be total cost for the whole year. Yeah, but you're right. It changed by time of year how much chemicals you need to use, eh? Yeah, yeah. Is this kind of what everyone's seeing, or are some people able to have anybody achieving? No, everyone experiencing higher chemical costs? Yeah, yeah. Okay, now a bit on wastewater collection. So this is kind of an interesting graph. I kind of geek out on the data here, but I like what this one shows me because this is the annual O&M cost for the system, and it shows it by replacement value. So as your system becomes more valuable because costs of pipe go up, your system extends, right? You build out another subdivision. So the cost of your system goes up, but your O&M budget basically either stays the same or goes down. And so that your dollar per value, so your budget for the value of your system is actually in real dollars is going down. So even if you had the same O&M budget for the last 10 years, in real dollars, that's actually a decreasing budget because you can buy, you know, what you could get for $100,000 today is a lot less than what you could have got for $100,000 10 years ago. And so I think this is a really interesting, and it's tough. O&M budgets are like the first thing to be cut or really hard to get increased, even if your system is expanding, even if the costs of pipes are going up, even if trucking costs are going up. So, and this is also what I talked about. You know, you can use this data to help build a business case, right? And you can take it and to say, you know, this is why I'm hurting. This is why I'm doing. I can't do more with less. I do less with less. This one is looking at sewer blockages. And so it's also looking at the different causes. So how much of your sewer blockages are from debris, grease, roots, structures, or unknown? And my related KPI is % of sewer cleaned. And not a shocker, but again, it's nice to see the data support it, is that the municipalities that are cleaning more are having fewer blockages. I know I'm kind of pointing out the obvious, but it's sometimes nice when the data supports them. Now we're looking at wastewater treatment. Any wastewater treatment folks in the? Yeah, okay, good. Okay, so some of the new things that are happening, we're having to keep changing our KPIs as you know, as life goes on. So for instance, we just added KPIs on PFAS. We didn't have that years ago. Then this is one, and how much of your treated effluent are you reusing? And again, it's a little hard to see on the screen here, but the lighter green is externally reusing it. So you're actually, you know, shipping it off to some industry next door or some farmers next door. And then what's yellow for me, but is sort of the darker color for you, is using it internally. Washing down things, whatever. Irrigation on site. This is another one that I thought was interesting. Anyone? Oh, you don't, but anyone else have odor complaints? Yeah, okay. So either you can beat a system like you guys built, or look at things like foul air treatment. So the bars are the number of odor complaints you're getting, and the dots show, do you have foul air treatment? So up here says yes. In the middle here says sort of partial, and down here says no, we don't have foul air treatment. So clearly municipalities that have odor complaints are putting in foul air treatments, but they're still getting complaints. So then I thought, well, does it just have to do with the number of residents that are nearby? And again, yes, I think there is some correlation. So the bars show the number of complaints, but the dots show the number of residents within a 1 kilometer radius. Or you just build an internal plant like CRD. Okay, this one, again, I'm just showing a few highlights here that I thought might be of interest. Percent of nitrogen removed. And I just pulled out the dot shows your the influent concentration and how much nitrogen you're actually removing, or the percent of it. A lot of nitrogen getting removed out there. But you can see there's a huge range in the effectiveness of removing nitrogen. And there are different, obviously people have different techniques they're using, but you can start to compare yourself with other plants. Overtime hours, I'm throwing this in for fun. This one is how much, so per staff member, on average, how much overtime are you having to pay out per staff member at your plant? And it ranges, right? There's some plants that hardly have any overtime. And there's some plants that have tons of overtime. So again, this isn't about who's worse, who's better. But you might, if you're, plant over here, you might be like, that's interesting. Why are we spending so much on overtime? And then you can start digging. Okay, another one. I'm killing you with data here with graphs. The other thing, oh yeah, this is an interesting one that we do for all our modules. And the idea is that you might pay someone for 40 hours a week, but they're actually not working 40 hours a week every week, because people are allowed to take vacations and people do get sick and they have training and what have you. And so how much of the time that someone's actually being paid are they able to work? And the important part about that is it comes around your O&M planning, because you can't plan out a 40-hour week for 52 weeks, a full O&M plan, because you're actually going to only have people working 80% of the time. And so so then you've got to think, okay, I've got to average 32 hours a week or whatever it is for your plant of actual staff time doing O&M. And you can see there's a big a range. So the purple is vacation. So yeah, okay, everyone takes vacation. But if people are allowed to bank vacation, then maybe all of a sudden you'll get a peak year. Or you have older staff with higher amounts of vacation. You got to kind of plan for that. Or you're a municipality that lets you bank time and then they take it, right? And all of a sudden, we're done with COVID and everyone's like, great, I can travel around. I'm spending all my bank time and see you later. You only have staff working 60% of the time at your plant. So those are some of the things that we're seeing post-COVID. Anyways, just some observations. Another one, wow, I'm doing a lot wastewater treatment. Okay, another one is looking at reactive hours. So how much of the time when you're maintaining your plant, is it like preventative maintenance or is it like reactive maintenance? And those are kind of disruptive because you're working on something and then, oh shoot, this is broken down, alarm's gone off, whatever, off you go and do that. And so you can see that some municipalities, like up to 40%, or some plants up to 40% is reactive. And so they're spending, almost half their day just, going from alarm to alarm. The other thing I thought I'd bring up to see if there's a relationship is, when was your plant built? And does that make a difference? So are the newer plants over here, do you have less reactive? So it's interesting to see that there's a plant here that was built in 2015, but they're doing tons of reactive maintenance. So you go and think, what's that about? But then there's some plants down here that were built in 1960s, barely any reactive maintenance. Or maybe they just don't have SCADA and they don't know when things go wrong. I don't know, but yeah, so it's really, it can be an eye-opener for plant operators. This is one, looking at the certification of your treatment plant staff. So this is the number of certified staff you have per 1,000 megaliter treated. And again, you can start to see the advantage of the larger plants that treat more water. You're probably likely to have more staff. But you can see the difference between, who's got a lot of this. Not only do they have a lot of staff, but they've got a lot of class 4 operators. And I did also put in the percent combined just to kind of show you. So this plant is about 10% combined. So we won't want to point fingers, but you could probably guess who that is. Okay. So what I wanted to do there was just to kind of show you a brief outline of some of the trends that we're seeing in the benchmarking in the world of water, wastewater, distribution, collection, treatment. That with brief highlights, there's hundreds of KPIs out there. I don't know if any of that was interesting for you, but any questions on some of the data I presented, what is benchmarking as a whole, the initiative? No? CRD, you participate in it. I don't know if you want to kind of, some of the things you've learned from it.
Yeah, well, we're more.
Oh yeah, thank you.
Thank you. We're newer,
Yeah.
being the wastewater plant's new to the CRD. The CRD has been participating for a long time, but wastewater is just jumping in now with both feet. It is there's a lot of questions. There's a lot of administrative stuff. You need to have a lot of data points. Luckily, we have SAP. We've got, preventative maintenance programs and all those kind of things in place that we can draw on. But so you kind of need to have some of those things before you kind of commit, because you're not going to be able to input any data points if you don't collect any data points. So a bit is just kind of the whole setup, and then going, okay, yeah, we want to participate in this, and then kind of jumping in. And I'm not sure how you approach Nancy or in general to dive in and become part of the whole pool, but there are lots of communities out there, and like I said, and for my work group, we're just trying to look at it, and definitely some of it is interesting, and trying to figure out how, and where we get the strength to be able to push back against like chemical prices that are just going like through to the moon, right? And stuff like that, and going, where's our ability to kind of pool and buy better, or have some, be able to push back against those industries a little bit, right? So, but it's still pretty, like, obviously new to us, and I mean, there might be, I'm not sure if anybody else participates, has a better, aspect of how they use this, but like I said, to me, it's just interesting now, and like I said, we're just trying to calibrate our data points and how we're going to provide better data, or if we weren't capturing a metric, what metric can we add?
Yeah. Anybody else have experience either with this initiative or any other benchmarking or data collection initiative, or that's worked for them? No. Okay.
Maybe Nancy, is this like an ongoing initiative that people can join, or is this a set group?
So it's every year. You start up every year and you kind of go through the process, and you end up with the data at the end of the year and the report and the workshop and all that good stuff. And then if you want to do it again, you sign up again next year. And so it's been going on every year since '97. So we have, 27 years worth of data, which is kind of nice. And I know certainly national entities, kind of, Canadian Water Network and things like that, are like so excited because, there's very few places, I think, in the world that have 27 years of data on operating of water and wastewater systems. So.
And how would a community or municipality start?
So if anyone is interested, they can contact me. I can give you my card or my contact information. And we can first, there are ways to start in. You can kind of just start in with one area and just sort of test and see how it goes, and learn about collecting data. And then as you get your systems built up, maybe just start with one plant, and then as things get going, then you throw in a second plant if you're interested, or put in your distribution system. So it depends how you're doing, and what, if you have a CMMS and you have a good GIS, if you're a collection or distribution, or depending on what you have. So yeah, that's about it. Yeah, so we tend to, I mean, any community can participate. And sometimes you'll have a big community, but they have like a small plant. So, you know, Halifax, which has some huge plants, but then they have like this tiny little plant just for like the airport and surrounding businesses. So you can be a small plant and still participate. Yeah, and there is also a filter. As you say, we normalize things by like either size or megaliter treated or kilometer of system. And there's also a filter. So you can say like, I only want to look at cities or utilities that have plants that are treating less than 20,000 people or whatever it is. You can do that. So you can filter out the information so you're comparing more apples to apples. Yeah.
Are there any other questions?
Yeah. Okay.
Okay, well, thank you so much, Nancy.
Yeah.
Let's give Nancy a warm round of applause.
Thank you. Thank you very much.